You can write the topic resonance. आज काफी लोग आए हैं. Usually you guys are not there.
Sir, today I joined early also.
Yeah, you joined early. Yeah. Okay, Abhinav, Aisha, and now we have. Okay, we have two Umar. So I can see Umar Abdullah. Yeah, sure. Mariam, it's fine.
Okay, sir. Thank you.
No problem. Okay. So I have got two Umar. Is any one of you Umar Muhammad Umar, or both of you are Umar Abdullah? Umar Abdullah, have you joined with two devices?
So I'm Muhammad Umar with small
You are
letters.
Muhammad Umar. Okay,
Small
fine.
letters.
Okay, yeah. So let us write the topic resonance. Okay. Now in resonance, you write shifting of pi electrons. What is resonance? You have seen resonance in chapter number 4, chemical bonding. So resonance is the shifting of pi electrons or lone pairs pi electrons or lone pair within a compound. Okay, within a compound. So I will try to tell you, this is, you can say that this is a kind of a reaction, but which is very fast, and it has some implication on the properties of the compound, Okay, next slide. This the different structure that we make now. We make resonating structure. You must have heard this word in chapter 4 again. Resonating structures. Resonating structures. Or hypothetical. Resonating structure are hypothetical, and it is a intramolecular. It is a intramolecular phenomena. Intramolecular means within one molecule itself. Next is we write a multiple resonating structure, more than one resonating structures, and the combination of all those resonating structure is known as resonance hybrid structure. The combination of all the resonating structures Yes, Aisha, if you want to. The combination
Okay,
of all
thank you, sir. Bye, sir.
by all the resonating structures is known as a resonance hybrid structure. Okay, resonance hybrid structure. I may be referring this to RHS. Okay, so write these 3 points down. Then I will ask you a question. Let me know if you're done. Okay, Reba is done. Okay, is there anyone who is still writing? Is there
but
anyone who's okay? All right. Okay, fine, right? Let me make two structures here. We have CH2 double bond CH, which has a bond with CH2, and here it has a positive charge. Okay, here it has a positive charge. Okay, now in this case, in this particular case, we can always identify electron electrophilic site. Electrophilic site means the site that is electron poor, which needs electron. So I have got 3 carbons, and all the electrophilic sites, they will be atoms. Okay, all the electrophilic sites, they will be atoms. So you have to first of all identify the electrophilic atom. So I have got 3 atoms of carbon, 1, 2, and 3. Now, can anyone tell me which of these 3 is electrophilic, which is electron poor, which will be attracting electron? Yes, Abhinav, Reba, Sara, Umar, anyone can answer? Or else I will pick someone to answer. Yes, Reba? You were not audible. Did you say something? Still not audible.
so
थोड़ा अभी कुछ
second
बोलो.
one.
Okay. Yes, Reba, what do you think? Which is electrophilic?
Number 3.
Number 3. Okay, fine. So Umar answers first. So can you, Umar, tell me why the second one is electrophilic? Yes, Umar. How is it electron poor? Yes, Umar. Yes, Umar, tell me. Okay, fine. Let me tell you. Second one is not electron poor, because if I see this carbon atom, it has 4 bonds. That means it has 8 electrons. This also has 4 bonds. That means it has 8 electrons. This carbon, it has 3 bonds. That means it has only 6 electrons, right? Now that is why if I compare the electrophilicity, then I would say obviously that the third one is the most electrophilic. Okay, can we see a site? Can we see a electron source here? Can we see an electron source? Yeah, obviously, if you have bonds, then you have electron source. Electrons, they lie on the bond. The reactive electrons, they will lie on the bonds. Now we have sigma bond, right? And we have then a pi bond. So if I compare these two things, then I would say that obviously the pi bond is what? The pi bond is more reactive, and it is a better electron source. It is a better electron source. So what is going to happen? This pi bond will move here. Okay, this pi bond will move here. And then what it is going to do? CH2, single bond, CH, double bond, and now CH2 will be there. Now this positive charge is completely gone, because this carbon, which previously had only 3 bonds, now it has 4 bonds. That is why the positive charge has gone. But if I look at the first carbon atom now, the first carbon atom had previously 4 bonds. Now it has only 3 bonds. That means we should give a positive charge to this carbon atom. Okay, so this is a kind of reaction. You can think of this as a kind of reaction, electron source to electron sink. Okay, electron source to electron sinks. But since it is a very intramolecular reaction, and it will be very, very, very fast. Okay, it will be so fast. It will be so fast that we can't even see this molecule. Neither can we see this molecule. Rather, what we will be seeing is a hybrid of these two, in which we will be seeing a CH2 with CH and CH2. Now, if I will measure the bond length of these carbons, all of them will have equal bond length. That means neither the structure is in this form, nor in this form. It is somewhere in the middle. Okay, and these are just a representation of these. These are just the representation of the real structure. Okay, this is just a representation. So this is resonating structure 1, and this is the resonating structure 2 that represent the real resonance hybrid structure. Now the CH2, if I will look at the CH2, in the resonating structure 1, it did not have any charge, but in the second structure, it had some charge. So what charge was that? Delta positive charge. Hence, I will write that it is delta positive, and this carbon also is delta positive. Now, if I look at this bond, it was in the first resonating structure, a double bond. In the second resonating structure, it is a single bond. That is why I would say that there is a partial double bond character. So first thing is that if you have in some resonating structure, the bonds are double bond. In some, the same bond is single bond. That means it has a partial double bond character. If there is an atom which has a charge in one resonating structure but not others, then you will be giving a delta charge. That means there is a partial charge on that particular atom. Okay, so you can write this down. Let me know if you're done. Then you'll write in what cases can we see the resonance. In what cases can we see the resonance? Okay, so write this down. Let me know if you're done. I hope you understand this. Electron source to electron sinks. It is a kind of a reaction. Okay, but that reaction is so fast that you are not able to identify, or you cannot see the resonating structures, but you will be seeing this resonance hybrid structure. This is the resonance hybrid structures. Okay, fine. So Sarah and Reba are done. Is there anyone who's still writing? Okay. Umar is also done. Muhammad Umar, let me know if you're done. Yes, Muhammad Umar. What happened? आप बोलना ही बंद कर दिया आपने.
Done, sir.
Okay, thank you. Now, right, conditions for resonance. Conditions for resonance. Right, resonance takes place when pi electrons, you write it like this, when pi electrons are in conjugation. Okay, when pi electrons are in conjugation. Now, what is conjugation? So right now, cases for conjugation. Cases for conjugation. Now, when I say now the pi electrons, these are in conjugation, it means that you will see what it means. The electron source and the electron sink, they will be separated by a sigma bond. Okay, electron source and sinks, it will be separated by a sigma bond. So first thing is that the first case will be there will be a pi bond followed by a sigma bond, and then it will be followed by a positive charge. Okay, now you can also write this as a double bond B, single bond C, and there will be a positive charge. Right, the second case in which you will have sigma, pi, and then you can either have lone pair or negative charge. Okay, lone pair, or you can have negative charge. So this can be some written as like this: a double bond B, single bond C, C as a lone pair, or a double bond B, single bond C, and C obviously it will have a lone pair, but with a negative charge also it can be there. Okay, with a negative charge. The third case would be pi, sigma. These are bonds. Okay, pi bond, sigma bond, and then there will be a free radical. You can write this case. You can see something a double bond B, single bond C, and C has a lone pair. C has a, sorry, not lone pair, but rather a free radical. The third case would be, sorry, the fourth case, pi, sigma, pi. So this will be a double bond B, single bond C, and double bond D, and double bond D. The fifth case will be if you have a lone pair, a sigma bond, and then there is a positive charge. Okay, a lone pair. So lone pair will be on an atom. So A is the atom which has lone pair. Then there is a sigma bond, and then there is a B atom which has a positive charge. Okay, so in this case also you will be seeing the resonance. In this case also you will be seeing the resonance. So please write the cases. Done, guys?
Sir.
Done, all of you? Okay, so write the first case. Acha. Let us do one question. So I will write some questions here and I will write some cases. In that you have to identify the type of resonance. Okay, which type of conjugation is there? Okay, which type of conjugation is there? So please write. Identify the type of resonance. Type of resonance in following. Okay. So here I can say that this is what? Pi, sigma, and then pi. Correct? Right. So in this case, I mean, similarly, you have to identify what are the different ones. Let me write this here. Pi, sigma, pi. Write B. Yeah. Complete this down, then let me know if you have doubt in any one of them, and we can talk about that. Okay, so did anyone solve equilibrium questions? We had a class on Wednesday. After that, did anyone solve any one question also? No one. What about you, Riba? आपने पुराने lectures देखे? ना, आपकी आवाज नहीं आ रही.
Yes, I watched the previous lecture.
Okay, so are you doing questions now?
Yes, sir, I did a few questions and then our exam dates were out, sir. So I was
Exam? कब से
exam
exam?
Feb
कब
20,
से है?
Feb 20.
अच्छा, Feb 20. अच्छा, आपका भी रियाद है इंडियन इंटरनेशनल
जी
स्कूल?
Yes, sir.
अच्छा अच्छा. सो तो क्या हो गया? अभी तो 20 फरवरी को है ना. इक्विलिब्रियम तो आ रहा है उसमें भी.
Yes, sir.
ओके. By the way, Riva, you know Hiba, na? I guess.
But
You know Hiba?
which one, sir?
In which? Sorry.
Sir, who Hiba? My sister also Hiba.
Actually, your sister is also Hiba. Sorry. No, Hiba, I mean your classmate. Do you have any classmate, Hiba?
Yes, sir.
Okay, okay, fine. So you both are in same section or just the same?
She just joined, sir.
She
Hiba,
just
Hiba.
joined?
She just joined. Like,
No, just joined one. No, not that Hiba then.
I don't know any other Hiba.
Okay, okay.
Maybe a senior, not my class.
Not your class or not your section?
Like not science batch.
She is in science. Biology. No idea. Okay. That is strange. Just joined means in 11th class. 11th class, huh?
Yes, sir.
अरे तो ये just join होगा 11th खत्म होने वाला है. Yes, I think that Hiba only then. She just joined. Okay. अच्छा उसको लेकिन नहीं पता था कि when your मतलब एग्जाम डेट कब से है. Done, guys? No, not done. Yes, you just have to identify. Can you please can you answer me? Abhinav, Mohammad Sheikh, Omar, Riba, Sara. How much is done? If you have doubt in any, or you do have no doubt in any of these questions, you can easily identify. No? Yes, Riba, you're not done with any? What happened, guys? Am I not audible? Why you all go silent mode like this? Can you please answer me at least in chat if you don't want to turn the mic on? It seems no one is here. Okay, fine, no problem. So in the B structure, we will have pi, sigma, and then positive charge. In the C structure, we'll have pi, sigma, and negative charge. Here we will be having pi, sigma, and positive charge. Here there will be pi, sigma, pi. Here we will have pi, sigma, pi, and also there is pi, sigma, and this oxygen, it will have lone pair electrons. This will be pi, sigma, lone pair also. Okay. Now similarly here, this will be pi, sigma, pi, and also pi, sigma, positive charge, right? Pi, sigma, positive charge. Here also you'll have pi, sigma, and this oxygen will have obviously lone pair, so pi, sigma, lone pair. And here there will be oxygen. If it is having a negative charge, that means there is lone pair. So this is lone pair, and then there is sigma, and then there is positive charge. Similarly here, there will be pi, sigma, pi, as well as pi, sigma, free radical. Here we will be having pi, sigma, and then N will have some free radicals. It doesn't matter. You can't say it now. I asked you so many times, what are you not understanding? And you were just silent. Now let the topic complete. And then if you have any doubt, then you can ask. Okay. Now you should write the first one. We will do with the pi, sigma, pi. Pi, sigma, pi. Or you can also write this case as A, double bond B, single bond C, and C will, sorry, to start with positive charge. C will have a positive charge. Now in this case, you can write an example, a simple example with that we have already seen, CH2 double bond CH, single bond CH2 positive. So this will be in resonance with CH2 single bond CH, double bond CH2, and there will be a positive charge here. The resonance hybrid of both of these structures would be CH2 CH CH2. Now, if I talk about this carbon atom, it will have a delta positive charge because one of the resonating structure is having a positive charge. Then if I talk about this bond, it is sometimes a double bond, sometimes a single bond. That is why I will say that it is a partial double bond. This carbon atom, it does not have any charge. It is as it is. It is making 4 bonds here. It is making 4 bonds here. It is making 3 sigma 1 pi. Here also it is making 3 sigma 1 pi. Moving on to the next bond. This bond is sometimes single, sometimes double, and hence it will be partial double bond. This CH2 is having a positive charge sometimes, it is not having positive charge sometimes. That is why this will be delta positive. Another good example would be discussing a benzene ring which is attached with a CH2 positive group. Now, in this case, you will start with there's a pi bond, there's a sigma bond, and there is carbon atom with a positive charge. So you can see pi sigma positive, and the electron movement will be going from here to here, and you will be forming the next resonating structure, which will look something like this. There will be a double bond CH2 because this pi bond has shifted itself, and the positive charge will be gone. These bonds are intact, so I will first of all make them. Then I will see that this carbon atom, it was having pi bond. Now it is also having pi bond, but this carbon atom, it has lost electron. That is why this will gain a positive charge, delta positive. Further, I can again see that we have same case, pi, sigma, and delta positive. So this electron will move here, and then it was going to form another structure in which we'll be having a pi bond here intact, and there will be a CH2 group here. And there will, sorry, not delta positive, I'm really sorry, this will be complete positive charge here. And the positive charge will move here. Actually, the positive charge is not moving, the pi bonds are moving, and that is why the consequence is that positive charge seems to be moving. Now, this pi bond will shift here, and then we can make another resonating structure. Okay, and then this will be pi bond here, this will be pi bond here, this will be double bond CH2, and the positive charge will be here. Now this pi bond can move here, and we are back to the same. The charge is back to the same atom that it started with, so we will stop. So we are going to stop here. CH2 positive. The pi bond will be here, here, and here, right? So these are the resonating structures. We will have 1, 2, 3, 4, 5 resonating structure for CH2 positive that is attached to a benzene ring. So the resonance hybrid will be, first of all, I will make a 6 carbon ring. Now I will make the CH2 group. So only sigma bonds. We will not be talking about the pi bonds. Now I can add in the pi bonds. I will look at this carbon atom. I will see that it is sometimes having positive charge, sometimes it is not having positive charge. So I will give the CH2 a delta positive sign. Now I will, if I talk about this bond, then this bond is sometimes single, and the other times it is partial, it is double bond. So hence this will be partial double bond character. Similarly, this, if I talk about this bond and all of these bonds, this will be partial double bond character. So I can write something like this. You can make a ring like this, which will denote that it is a partial double bond. If I talk about this carbon atom, it is sometimes having a positive charge. The other times it is not having positive charge. So this will be delta positive. This carbon atom, it does not have any charge. So I will just keep it like this. This carbon atom, it is having a delta positive charge. So I will write delta positive charge here. This carbon is also having sometimes delta positive charge. So I'll write this delta positive charge as something like this. Okay, so what insight we can get is that if I write this structure and if I do the reactions with this structure, the structure that I started with, then in this structure I can see that there is only one electrophilic site, that is this carbon atom. But in fact, this structure is one of the structures that is possible. And this is not the real structure. This is a hypothetical structure because this is one of the resonating structures. The real structure is the real structure is this structure, that is the RHS. And I can see here that there is not one, but rather I can say there is effectively 3 electrophilic site. Since this is also ortho and this is also ortho, I cannot say that the ortho positions are different. They are same ortho positions, and hence I can say that this carbon atom is a electrophilic site, this carbon atom is an electrophilic site, this carbon atom is an electrophilic site. Now I can say that this and this sites are essentially same. That is why I'm not considering the 4th one. Okay, so you can write this down. Let me know if you're done. This is the resonance hybrid structure, RHS. It is just a movement of pi electrons. It is just a movement of pi electrons from electron source to electron sink, nothing else. Okay, Reba is done. Is there anyone who is still writing?
So I'm writing.
Okay. Okay, Sarah is done, Reba is done. Umar Abdullah is done.
Done, sir.
Okay. Write the second case. Write the second case. So I'm just drawing something. You will write the resonating structure for that. Okay. I'm showing the arrow. Right. You have to write this. You can copy this, but I am writing the second one now. We will have pi sigma lone pair. Okay. We can write this as A double bond B, single bond C, and C has a lone pair. Or this will be same case if we have A double bond B, single bond C, and C has a negative charge. This negative charge will only be possible if you have a extra pair of electrons, Okay. Now in this, we can start with a simple example of CH2 double bond CH, single bond CH2, and this CH2 has a negative charge here. In this case, the electron source will be this negative charge that will form a bond here, and this pi bond will shift towards like this. So we'll have CH2 single bond CH double bond CH2, and this carbon atom will now get a negative charge. So I can write this resonance hybrid as CH2, just making the atoms in the sigma bonds CH CH2. Now we'll talk about this carbon atom, sometimes having a negative charge, sometimes neutral, hence this will be delta negative. This bond is sometimes sigma, sometimes it is a double bond, single and double, so partial double bond character will be there. This carbon atom is not changing anything, neither its charge, and this pi bond will be sometimes pi, sometimes sigma. This is a partial double bond, and this carbon atom will also be having a delta negative charge. Okay, a similar case you can make if you have CH2 double bond CH, single bond OH. Now we know that there are 2 lone pair electrons in the oxygen atom. These lone pair electrons will move here, and then this pi bond will move here, and then you will be making CH2 negative, sigma bond CH double bond OH and positive. Okay. Now you can see one thing, that this system was completely neutral, and this complete molecule is also net neutral. There is positive and negative charge, but it will cancel each other, because if we calculate the net charge, it will be again neutral. Now in this case, what I can do, I can also make resonance hybrid structure in which you will be having CH2 sigma CH single bond OH. The CH2 will be having a delta negative charge, and there will be a partial double bond character here. There will be a partial double bond character here. Okay, this oxygen will be getting a O delta positive. Okay, this oxygen will be getting a delta positive charge. Okay, write this down. Let me know if you're done. Now we can completely see that if I just look at this particular molecule, and this is the real molecule. Okay, this is the real molecule because this is having another structure which is contributing to the real properties. Now this structure and this structure is very different. We can see that the electron source, I would have said that oxygen is the electron source, but I can see that there is a delta positive charge here. Rather, this CH2, which will be a greater nucleophile, and it will be attacking more easily than the oxygen atom. Okay, please write this down. Let me know if you're done. If I had a electrophilic substance, then I would have attacked with oxygen. If I had known only the structure, but now since I know the resonance, I can say that if I have an electrophile, then the preferable attack will be by the carbon atom and not the oxygen atom. Okay, so this is the insight that you get if you know resonance. Let me know if you're done, guys. We can move to something different.
So what does the dot represent on the lines?
Partial double bond character. Partial double bond character. Yes, Umar, we know that. I know that. When are your exams, Umar? Not informed yet. Okay. Yeah. No. I was asking Umar Abdullah. In your school, lot of portions to complete in school. अच्छा, रियाद में पहला केमिस्ट्री है. That's good. That's better. अच्छा, 20 से कब तक है आप लोग का उम्र?
March 3, sir.
March 3. Okay.
Last paper
Okay.
physics.
Last is what?
Physics, sir.
Physics is last. Okay. So we can start from mid of March now, at least. What do you think for 12th standard?
Maybe, sir.
है ना? It will be good if I start from the mid of March. At least we can start a few batches, and then we can. There are some schools, I don't know whether they will be done till mid-March or not. Some schools are pretty late. Some schools are so early, they are starting in somewhere around mid of Feb or the first week of Feb also, some schools. Okay. Okay, so next is, right, the next one. We have done how much? We have done 2. Okay, one more I will give that you have to write. On your own, CH2, double bond, CH single bond, NH2. This will have a lone pair. So you can see, I am showing the arrows. You just have to make the structure, okay? So this is the third one, right? So the third one, pi sigma, free radical. You can write this as A double bond B, single bond C, and C has a free radical, single electron. Example, we'll start with simple example, CH2, double bond CH, single bond CH2, and a free radical. Now, obviously, you can see that if you see one electron like this, it is very tempting to say that it is an electron source, but it is not an electron source. Rather, it is an electron poor site, because this carbon atom, it only has, if you see this, there are 2 hydrogens. That means it has how many bonds? It has 6 bonds and 1 free radical. That means 7 electrons. So obviously it is what? It is an electron poor site. It is not an electron rich site. Okay. So in this case, the electron movement will be, I'll be writing 2 things here. First of all, see, there will be electron movement, something like this. This pi bond will break into 2. It will be giving out the electrons like this. Okay. And we will be first of all making CH2, single bond CH, single bond CH2. Okay, now free radical, and free radical. Now these two free radical will combine with each other. Okay, and they will be forming CH2. This will be free radical, sigma bond CH, double bond CH2. Okay, now this is also shown sometimes simply as CH2 double bond CH, single bond CH2 free radical. They show it like this. So one electron transfer. Okay, so the resonance hybrid that I will be making will be CH2 single CH, single CH2. This will be, I can write delta free radical here. Okay, delta free radical here. Okay, and this will be partial double bond. This will be partial double bond, because essentially as soon as this particular lone pair it comes here, it instantly forms bond with this particular carbon atom. Okay, so this is like a very long picture, but it essentially happens like this. And you have to remember that this is the RHS. RHS means resonance hybrid structure. Write this down. Let me know if you're done. Done, guys? Yes or no?
Answer.
Done. Okay. I write the next one. Phi sigma pi. This is what? This is the fourth one, right? Also refer this to A double bond B, single bond C, double bond D. अच्छा ऊपर में हमने दिया था कि example. Yeah, I have given this. Okay. Okay. So I'll start with the most important one. If you have CH2 with a single bond CH, CH2 double bond CH, then you have a single bond CH, then you have a double bond O. Okay. Now this is an example of aldehyde if you can't see it. Hydrogen, double bond O. So CHO group, it is what? It is a aldehyde. Now in this case, first of all, what will happen? This pi bond will break and it will move towards more electronegative atom like this. And what you will be seeing is a structure which is like this. Carbon, hydrogen, single bond, oxygen, and there will be positive charge on oxygen. No, there will be a negative charge on oxygen because it has taken electrons. There will be positive charge on carbon. Now I can see A double bond B, single bond C, and C has a positive charge. So the pi bond will move like this, and you will get a structure which is CH2 positive, single bond CH, double bond CH, and there will be a single bond O negative. Okay, so now you can see the initial one was neutral, the second one is also neutral, and the third one is also neutral. Net neutrality is maintained. If there is a positive charge in some atom, there should be a negative charge in the other atom. There should be a negative charge in other atom. Now, in this case, I have got 3 resonating structure, and I can write the resonance hybrid for all of these 3. So first of all, I will write all the atoms as it is with only sigma single bonds, CH, single bond CH, and double bond. Sorry, not double bond. Rather, I would also make this a single bond, because initially I just have to make a skeleton of single bonds. Then I will judge about the atoms and the bonds. This carbon atom, I can see that it is neutral. Neutral. There is a positive charge here. This will be delta positive. Then, if I look at the next structure, next bond here, the next fragment in the structure, that is a bond. It is a pi bond here. Here it is a pi bond. Here it is a single. Double, double, and single. That means there is a partial double bond character in this also. It is not a complete double bond. If I look at this carbon atom, it's neutral. It is neutral here, and it is also neutral here. So I will not write any charge on this atom. Now, if I look at this particular bond, it is a single bond. Here also it is single, but here it is double bond. So I will write a partial double bond character in this case here. Next, if I look at this carbon atom, then neutral, positive, neutral. So there's a delta positive. And if I look at this bond here, it is obviously at a partial double bond character because it has a double bond here, it has a single bond here, it has a single bond here. And in this case, this oxygen, it will be delta negative. In this case, this will be delta negative. Now you can see that how this carbon is also what? How this carbon is also a electrophilic carbon atom. It is also a electrophilic carbon atom. Okay, so please write this down. Let me know if you're done. So here we have 2 electrophilic sites, this carbon and that carbon. Both are electrophilic. Okay. Another example will be CH2, double bond CH, single bond CH, double bond CH2. Now, in this case, what will happen? You will be directly transferring the electron here, like this. And this will move like this. You'll have CH2. Now, if you have transferred the electron, this will be positive charge here. There will be a single bond, CH, double bond, CH, single bond, CH2, negative. The resonance hybrid of these 2 structures, it will be CH2, CH, CH, CH2, delta positive, double partial double bond, partial double bond, partial double bond, delta negative. Write this down. Let me know if you're done. Is there anyone who's still writing? No. Write the last one, that is lone pair sigma and then positive charge.
So can you scroll up?
Okay. Right here, lone pair sigma, then a positive charge. Or you can write something as there is a lone pair on A atom, a sigma bond, B atom, and B atom has a positive charge. Okay, B atom can have a positive charge or a vacant orbital also, or a vacant p orbital. Vacant p orbital. Example will be, first of all, you can write. So you have CH3 single bond oxygen atom, which obviously has 2 lone pairs, and then you will have a CH2 positive. So you can see there's a lone pair, there's sigma, and there's positive charge. So this lone pair, you can say it will shift like this, and you can write a resonance hybrid structure, which is CH3 single bond oxygen, double bond CH2. Oxygen will get a positive charge, and the carbon will be getting a neutral thing. It will be neutral. Now you can write the structure, resonance hybrid structure, which is CH3 single oxygen single CH2. This is completely single. This is partial double bond character here. There is a delta positive charge here. There is a nothing, no charge is there. Okay. Sorry, delta positive charge here also. Sorry. Similarly, what you will do, you will write for CH3 single bond nitrogen. A hydrogen is attached to nitrogen here. Then you have a CH2 positive. This nitrogen has a lone pair electron. It will shift like this. And you will write the resonating structure and also the resonance hybrid structure. Write this down, guys. Let me know if you're done.
Done, sir.
What about others? Everyone done? Let me know if you're done, and then we will talk about the stability of resonating structures. Okay, which of the resonating structure is more stable, and the one which is more stable, that will contribute more towards the resonance hybrid structure. Okay. Yes, all of you done? Can I stop sharing the screen?
Yes, sir.
Okay, take a screenshot if you're not done, right? Okay. Wait for 5 seconds. 5, 4, 3,